Hey guys, this is continuing straight on from the previous video, where I'm going to be looking at the relationship between the total stress, the effective stress, the excess pore water pressure, and settlement. So in the previous video, we saw how over time we get settlement, a change in pore water pressure, if the total stress remains the same, and we get a change in the effective stress. So we're going to plot all that now to get a better understanding of what's going on. So the first graph we're going to draw is time against the total stress. Now this total stress is not changing at any time. So for example, we've applied 20 kPa here. Our system is experiencing 80 kPa. Now although pore water pressure is escaping, the system is still experiencing 80 kPa due to this induced load of 20 kPa in addition to the initial condition. So the 80 kPa is inside this system. That system does not change. Okay, the total stress inside here of 80 kPa is not changing. So that remains the same. The total stress versus time. The time against excess pore water pressure. So this is not pore water pressure, it's excess pore water pressure. So excess pore water pressure. So as you can see, at a particular time we get a maximum pore water pressure. We had it at 30 kPa, which then reduces as the water is allowed to escape, and it takes us back to our initial pore water pressure we had at the beginning. So the excess pore water pressure goes to zero. So we still have a pore water pressure in the system, but the excess pore water pressure has gone to zero as all the excess pore water pressure has escaped. So if we were to graph this diagram, it would look something like this. So as time goes on, the water escapes and the excess pore water pressure reduces. The next graph we can draw is the effective stress against time. So effective stress is what the soil particles experience, and that will increase with time. So these are inverse relationships, the excess pore water pressure and the effective stress. As the pore water pressure escapes, it can't take as much load, which means that the soil has to take more load, which is the effective stress. And the final thing we can graph is the time against the settlement. Okay, so time against settlement, we will get some level of immediate settlement, and that's going to increase until we get to time infinity, where all the excess pore water pressure has escaped and there's no more settlement occurring. So we have immediate settlement, which is this initial immediate settlement there, and then the long-term settlement, which is that value there. So long-term settlement, which occurs as the excess pore water pressure escapes, causing more settlement to occur. So anyway guys, I hope this summarizes nicely what's going on and gives you an appreciation for why settlement doesn't occur instantaneously but occurs over time, as it takes time for the excess pore water pressure to escape. In the next couple of videos, we're going to be looking at some examples where we calculate like settlements at different times. We can calculate pore water pressures, and we're going to be looking at different graphs which enable us to do that. So I hope that helps.